So before start the actual project explanation, I request you please subscribe my channel. So you can see on the screen up till now I have uploaded more than 66 video on Raspberry Pi. The Raspberry Pi with IoT, that is all this video. Then also IoT with Arduino, all this video are 26. And recently we started the new series on the PIC microcontroller. Before that I also cover the project on the Python web application. So if you want to learn Python, IoT, Raspberry Pi, Arduino, PIC from the scratch and from freely, then please subscribe my channel, please support me. And the most important part is whatever the code I have explained, whatever the project I have created on this YouTube channel, all these projects are freely available. You no need to pay anything for this project. So just if only point is you should watch complete video and you should follow my process. So if you want to learn something from the scratch and freely, then support me and please subscribe my channel and please click on like button. How we can design and develop a surveillance system robot by using Raspberry Pi and camera. So you can see on the screen we have the Raspberry Pi, camera module and mobile application. Through this mobile application we can see the live feed from this camera on this mobile application. Also we can control the direction of this Raspberry Pi through this button. You can see there are 5 buttons: forward, right, backward, left and stop. So through this button you can easily control the direction of this Raspberry Pi. Also you can see the live streaming from this camera on this mobile application. So in this video I will tell you what will be the how you can design this project by yourself. I will tell you how you can connect all the hardware like motor, the L293 IC with the Raspberry Pi. Then also I will explain how you can design this mobile application. Okay, so please watch this complete video so that you can design and develop this project by yourself. No need to pay any single cost for this project. This project is completely free and no need to pay any single rupees for this project. Only criteria is you have to watch my complete video, each and every part of this video, so that you can design and develop this project by yourself. Okay, first we will see the practical demonstration of this project, then we will see the hardware connection, and then we will see the program part of this project. So first let's see the practical demonstration of this project. Now let's see the practical demonstration of this project. So you can see I have the Raspberry Pi robot is here, camera is there, and from that camera continuously live video is coming. You can see on my mobile application you can see live video is there. Now I will move forward, left, right and some direction of this Raspberry Pi. Now you can see mobile window on the left side on this screen. Now I will move my Raspberry Pi forward, reverse, left, right direction quickly. So let's say forward. You can see it is moving forward. I am continuously giving the live feed. Then after that I will use stop button. Okay, it will stop. Now I will move to the backward side. Okay, backward. Then again you can see live feed is there. Then stop. Then after that again forward, and then again right side, then again left side, and stop. Okay, now one point is when you press the right side button, then Raspberry Pi continuously move to the clockwise direction. So it will continuously move to the clockwise direction till you press the next button. So like this. So once I press the right side, then it will continuously move to the clockwise direction continuously for infinite number of times, and it can give the completely surveillance system view on my mobile. So once I press the forward button, then it will move forward, and again backward. Then if I give the left side movement, then it will stop. So once I give the left side movement, then it will again continuously move to the left side till next button press. So left side, you can see left side continuously giving the direction, then stop. Then now quickly I will ride my robot. So forward, left, forward, left, forward. So you can see my image also, my footage also. Forward, then left, then again forward, then left, then stop. Now let's move our Raspberry Pi to the another room so that we can see the feed from the another room. So let's move that. So you can see it is moving forward. So you can see, I can see the different objects from the room, so I can easily control my Raspberry Pi. So I hope you understand the complete project flow and how to control Raspberry Pi. Now we will see the hardware connection, and then we will see the program part of this project. Now let's see the hardware connection. So first we start with the motor chassis. So in motor chassis, very important part is you should have the 4 motor like this. You can use any chassis and any motor, but you should have the 4 motor. So like this I have the 4 motor. So basically when you have the motor, each motor having 2 pins. You can see one pin is here and second pin is here. Same for the other motor having 2 pins, one pin here, second pin is here. So every motor you can see there are 2 pins. So you have to solder the 2 pins, and you can take the wire this like this, and there should be the 2 wires from the each motor. There is no positive and negative terminal for the motor. You just need the 2 wires from the each motor. Okay, so this is very basic part and very important part. You should have the motor chassis and 4 motor, and each motor having the 2 pins. Okay, so how these pins looks like I will show you. So here you can see each motor having the 2 pins. Here also like this motor also, these 2 motors are also having the 2 pins, and from the each 2 pins I have connected 2 wires. You can see 2 wires come from here, 2 wires come from here. So each motor having 2 wires here. Again this motor having 2 wires. So totally I have pair of 4. So totally I have 8 wire for the 4 motor. Okay, so each motor having the 2 wires. So now quickly I will connect the chassis and bring this wire up. Okay, once you have the 4 pins, like 8 pin up for your 4 motors, you can see all my from my chassis there are 8 pins are coming. Now we have to find out the direction of this motor. So like you can see there are 4 motors, and these 2 motors are for the left side, these 2 motors are for the right side. So when I give the supply, then these 2 motors should be rotated forward also, and these 2 motor should rotate forward. So direction should be same for the each motor. So how to find the direction, that we will see now. Okay, for the external power supply, you can see I use the power bank, which rating is, you can see here, 5 volt, 5 volt 2 ampere, 5 volt 2 ampere, 5 volt 1 ampere, 5 volt 2 ampere rating. The 2 USB we will use for our project. So ultimately you can use your this power bank, which is used for to charge the mobile. Same power, from the same power bank we will provide the power to our Arduino and all the hardware. Okay, to give the power, very important part is you should have the USB cable, and one side of USB cable you can cut directly here. Once you cut, you will find the 4 pins. From that 4 pins you will find the 2 pin, red and black. So red means for 5 volt supply, and black means ground. Other 2 pin you can ignore. Okay, so only these 2 pins we need. It is very simple. You can take any USB pin from your mobile, like this mobile charger cable. So you can cut from here. Once you cut from here, then you will get this 4 wires. Then you have to take only negative and positive wires only. Other wire you can ignore. So this is one point you have to do. Now what you have to do, from your power bank you can connect this wire. Okay, from the power bank you can give the, like you can plug this wire here. Okay, Okay, once I plug, then I have the power supply at this pin. Okay, 5V power supply. Then I will check the direction of the motor. So how to check the direction? Just connect one wire from one motor each. Like, let's take this random wire first, this, and then another wire from the same motor. So you can see my direction is reverse, like rotating at reverse direction. So that means when I connect the positive pin for this pin, like from this pin, this is the positive pin and this is the negative pin. So once I connect this negative pin here and positive pin here, then my direction is reverse for this motor. Okay, same, and find out the direction of the motor, second motor. Okay, so this first motor we understood, this is the negative pin, this is the positive pin. Same for this motor, you can connect like this. Another motor having two pins, connect like this. So again I find out this is the reverse direction. So ultimately I found out this is the negative pin for the both motor. Okay, so I will connect these two pins here, one negative pin for the first motor and another negative pin from the second motor. Okay, so connect that two pin here. Then positive pin for this motor and positive pin for this motor, connect here. So ultimately what I did, I have sorted the two pins. Again I will give the power supply to check whether once I give positive negative, then both motors should rotate in the same direction. So just connect power supply. Okay, now I can see my both motor are rotating in the same direction. So this is the first step you have to do to find out the direction of the motor. With the same step you can find out the direction of the these two motor. Okay, so again I will take the random two pin from this motor. So now we need the direction negative, like this side direction we require. Okay, so motor should be rotated in anti-clockwise direction. So again from the power supply I will take random two pin and connect here. Okay, now I can see my motor is rotating anti-clockwise direction. For the same another motor I will again check the direction. So this is also anti-clockwise. Okay, so ultimately I found out these two pin are the negative pin. I will short it again here. And these two pins for these two motors. Okay, now initially we have the 8 pin, now we have the 4 pin only. Okay, this 2 pin from this 2 motor, this 4 motor, this 2 pin from this 4 motor. Okay, these 2 motors. Okay, so ultimately we have the 4 pin now. Now this 4 pin should be connected to our L293D motor driver IC. Okay, now first see the L293D motor driver L2938 motor driver IC connection. So each L2938 motor driver IC having all these pins. So very important pins are this one. You can see here you should have the jumper. If you don't have the jumper, then your external power supply will not work. So you should have the jumper here. So verify here all the 3 jumpers should be there. Okay, then you can see these 2 pins are nothing but the motor. So these 2 pins are nothing but the motor output pin. So whatever the motor output, like from this side we have the 2 pins, the 2 pins we will connect here, and this side we have that 2 pins, then that 2 pins we will connect here. Okay, so like you can see this, like these 2 pins are here and these 2 pins are here. Okay, then at this side you can see there are middle one are the ground pin for this motor driver IC, This is the 5V supply which is coming from the Arduino, and this is the 12V supply which is coming from our power supply, like this power bank. Okay, then there are 4 pins. So these 4 pins are nothing but the input pins. So how this input pin work, like let's say this pin and first pin and second pin are connected to these pins. Okay, so this first pin are connected here, second pin are connected here. So whenever we give the 5V like Arduino output, that is the 5V on this pin, then here the 12V output is generated. Whatever the supply you will give here, that supply generated here 12V. And second pin, if you give the ground, then ground supply generated here. Same for this pin. So if you give the one here, then this pin get the 12V. And if you give the ground, then this pin will give the ground. Then motor will rotate in clockwise direction. So in the anti-clockwise direction, you have to reverse the pin. Like on the first pin you can give the 0, second pin you can give the 1. So then here it will generate the 12V and here it will generate the 0. Then motor will be rotated in anti-clockwise direction. So like this is the basic idea. I hope you understand the basic idea of L29 3D motor driver IC. Let's connect quickly. Okay, I will place power supply here. Okay, so first connect this pin to this side. Okay, first one pin of motor driver IC, this side, first one pin. Okay, okay, now connect this second pin to the second pin of this motor driver here. Okay, for the same now check the power supply again. You can directly give one positive, one negative pin here. So at any side you can give positive, negative pin, there is no issue. Let's say this is the positive pin and this is the negative pin. Then my two motors should be rotated. So this one you can verify. You can see my motor is rotating. Okay, you can give the positive, negative pin and just check which direction your motor is rotating. Your two motor should be rotated in the same direction. Okay, now I can see my motor rotating in the same direction, that is the clockwise direction. Okay, so this is done. So here I connected the positive pin, here I connected the negative pin. Just focus on that one. So on positive side, this pin. So this pin we have connected positive, this pin we have connected negative. That is very important, we require later. So again connect the random two pins here, this side. And second pin this side. Motor output 1 we give positive supply, 2 we have given the negative supply. Same for motor output 3 we will give the positive, motor output 4 we will give the negative. So 3 we will give the positive, because 1 we given the positive, so less number we give the positive again. So motor should be rotating clockwise direction again, that side motor. Okay, yeah, perfect. So it is rotating clockwise direction. So if your motor is rotating anti-clockwise direction, just swap these two pins. Okay, 4 motor should be rotated in same direction. Now this is a very important step you have to do. Okay, once you connect all the hardware, that is motor with L293 IC, The next is we have to check the Raspberry Pi. Now you can see I am using the Raspberry Pi 3B plus. You can use any Raspberry Pi, there is no issue. On Raspberry Pi you can see all the pin number. The odd pin number are at this side, even pin number are at this side. You can stick the paper on that pin number so that you can easily identify the pin number while doing the connection. Okay, so I will place Raspberry Pi here. Now second hardware is this one. This is common VCC and common ground circuit. It is nothing but the simple circuit where common point are shorted. So whenever I need the VCC, I will take from here, that is 5 volt. Whenever I need the ground, I will take from here. Whenever I need the ground, I will take from here, and whenever I need the VCC, I will take from here. So this is the very simple. You can use the breadboard also, there is no issue, or 0 PCB. Now the 4 number pin from the Raspberry Pi, that is the 5 volt pin, should be connected to common 5 volt here. So this is the common 5 volt. I have connected 4 number pin here. Then 6 number pin from the Raspberry Pi should be ground, and that should be connected to common ground. Okay, so 6 number pin is connected to common ground. That is the second connection that we have done. Now L29 3D motor driver IC having one 5 volt supply. So take the positive pin from here, from common pin, and connect that common pin to the 5 volt supply here. Okay, so this is the 5 volt supply. I will connect just here. Take the negative pin from this common supply, that is ground pin, connect that ground pin to the common ground. Okay, that common ground is ground for this L2938 IC, that is the middle one pin. Okay, this is the very basic part you have to do. Okay, now next part is this USB cable power supply. So USB cable positive voltage, that is red pin, should be connected to motor driver 12 volt supply. Okay, red pin should be connected to motor driver 12 volt supply. And this ground pin should be connected to again middle one pin. So middle one, there is already ground from the arduino. Just plug out there and take the common ground. So there should be 2 ground pin, one from the power supply and one from the arduino. Then after that, on L2938 IC we have the IN 1, IN 2, IN 3, IN 4 pins. So once you flap this L2938 IC driver, motor driver, then you will find the IN 1, IN 2, IN 3, IN 4 at the back end. Okay, so very simple connection. You just need the 4 pin from here. Okay, and first connect the IN 1 pin. So first connect the IN 1 pin to the 29 number pin of Raspberry Pi. Then IN 2 pin should be connected to 31 number pin of Raspberry Pi, 29, then 31. Then IN 3 pin should be connected to 33 number pin of Raspberry Pi. And IN 4 last pin should be connected to 35 number pin of Raspberry Pi. Okay, I again repeat, IN 1 should be connected to 29 number, IN 2 should be connected to 31 number, IN 3 should be connected to 33 number, and IN 4 should be connected to 35 number. So this is very basic circuit. Then we have our power bank here, mobile power bank. You can use any power bank that having 5 volt 2 ampere supply. And the another is USB. You can see camera, it is USB camera. You can just connect this USB camera to here on Raspberry Pi. Okay, So this is very basic simple circuit. And then for the power, you can use the same mobile power bank. From the power bank you can take the wire, you can take this wire, you can connect to the power bank. You no need to purchase any another another battery. You can use home power bank. Okay, so just connect this to the Raspberry Pi, so it will provide the power to Raspberry Pi. Then again this is the second wire is coming for this L2938 power. Okay, that should be connected to another here. So this is the complete connection about this project. I hope you understand the complete connection about this project. Now once we give the power, then we have to connect HDMI cable to Raspberry Pi to turn on the monitor and to run the code. Once you run the code, then we will check the whether our hardware is working or not. So I will connect the HDMI cable to here. Okay, now I have connected the HDMI cable from my monitor to Raspberry Pi. Already we have given the power, so you have to just run the code. And I will run the code. You can see the Raspberry Pi monitor is open. I will run the code. So how to run the code, that we will see again. No need to confuse here. Okay, once you run the code, you can remove this HDMI cable from this Raspberry Pi. No need HDMI cable now because you have already run the code. Raspberry Pi itself running that program internally. So now this is the complete wireless connection. Okay, now I am moving the Raspberry Pi to forward direction. Just whether check our Raspberry Pi working forward, left, right, stop, and then backward. Live feed also I can see here. So in this way we have completed the hardware connection of this Raspberry Pi. I hope you understand the hardware connection. Now we will see the programming part of this Raspberry Pi. Okay, now let's see the programming part of this project. So very important point is you should download my control robot using web page folder from my web page link. The web page link given in the description of this video. So go to the description, download from the web page. There is download button. Click on that download button. You will find this folder. That may be in the zip file. You have to unzip that one. Once you unzip that one, you will get this folder. Then after that, inside that folder, you have to go to the link. Once you go to the link, open that link in the text editor. Copy this Flash library command. You have to install that Flash library. So how to install? Just go to the Raspberry Pi terminal. So here should be Raspberry Pi terminal. So like this Raspberry Pi terminal, right click here and paste. Copy that one, copy this one, right click, copy this one, go to terminal, right click and paste. Okay, and press enter. So once you press enter, the Flash will be installed in your Raspberry Pi. It is very important you should install the Flash library. You can use this command and also pipe3 also for the Python 3. Okay, so sudo pipe3 and press enter. So these two commands you have to install, you have to use to install the Flash in your Raspberry Pi. So I will write the command here, pipe3, pipe2, sorry, simple pipe for Python 2. Also you can use another command before that one. You can use sudo apt get update to update your Raspberry Pi, and sudo apt get upgrade. So these are the basic command you have to use before to install the Flash. So likewise you have to install all the Flash command in your Raspberry Pi. You can see I have already installed the Flash so that it is giving my requirement is satisfied. So you can use all this command one by one. Copy this command or already updated. So I will not do that one. Copy and paste. You can do update, upgrade, then pipe3, then pipe2, like this command you can use. Okay, so this file you have to open and run the command to install the Flash in your Raspberry Pi. Okay, so once you install the Flash, you can open the code from that folder. This is the code. You can right click here, open with Python 2. You can double click here, it can open with the Thony browser. Anywhere you can use, there is no issue. Okay, so you can use with Python 2 also, you can use with the Thony browser also, there is no issue. So from the code, let's see importance of each and every line. So whatever the library we need for this project, that imported here, Flash library, GPI library, CV2 library for image processing, and the time library for time delay. Then we are using the Raspberry Pi in the board, so that we are using this line. Then we have to turn on some warning, that's why we are using this line. So you can see motor IN1, IN2, IN3, IN4, that is the that is the L2938 motor driver IC number. IN1 should be connected to 29 number, IN2 should be connected to 33, IN3 should be 33, and IN4 should be 35. So these are the Raspberry Pi pins that we use. Then we have to set all these pin as output pin, so that we are using, so IN1 should be connected to 29 number, IN2 should be connected to 31 number, IN3 should be connected to 33 number, and IN4 should be connected to 35 number. So all these are the motor pin that is connected to our Raspberry Pi that we define here. Then you can see GPIO.setup, we have to set up all the pin as a output pin, so that we are giving here GPIO.setup as GPIO.out, so all the pin work as output pin, so all the pins we are considered as output. Then initially we have to give the false command on that pin, so that our robot will not move once we give the power, so that we are using the false command on all the pins. Then we have to define our object to capture the image from the camera, so that's why here we define the object. You can use the any camera, there is no issue. You can use the only USB camera, you can use the Raspberry Pi camera also. And once you use the Raspberry Pi camera, you can change here from -0 to -1, or you can try with the 1, or you can try with a 2. So like this you can change. I am using the USB camera, that's why I have given here 0. Okay, another important point is, if you are using the Raspberry Pi camera, you have to enable the Raspberry Pi camera from the configuration, from the preferences, from the Raspberry Pi configuration interface, and here you have to turn on the Raspberry Pi camera. If it's not turned on, your camera will not work. Click on enable, click on OK. Okay, so that step you have to follow. Then URL address, this is the web page address. How to find this web page address? Just go to the terminal again, Raspberry Pi terminal, you can open from here, and here you can type the command ifconfig. Okay, so this command you can type. I will copy this command and paste into the link folder, so that it will be visible for you later. So this command ifconfig, so this command, it is used to find the IP address of your Raspberry Pi. So ifconfig, paste and enter. So once you enter, you can see this is the at the end. Okay, at the end in the WLAN 0, you will find the one IP address 192.168.0.102. In your case it will be 103.105. Just copy that address and paste here. Inside here you can see 192.168.0.102 inside this double colon. Okay, so this is the IP address of your Raspberry Pi. Then we are giving the flash object for to access the flash different functionality. Then our project first start from the here main loop. Our address will be start with the port address 8080. Then when you give the in URL, let's say when I run the code, so let's say when I run the code from this run and run button, you can use Python this Raspberry Pi shell also to run the code. There is no issue. Once you run the code, okay, wait. Okay, sorry, I have missed one step. You have to install the CV2 library also in your Raspberry Pi. So how to install CV2 library, that so CV2 library also you have to install in your Raspberry Pi. So how to install that CV2 library, that I already explained in my various video. You can watch my past video like face mask detection video or face attendance system video, any video, and try to install CV2 library in your Raspberry Pi. And this code you have to open in Python 3 because we are using the CV2 library. So I forgot that one. Okay, in Python 3 you have to open and just where we are, just click on run button. Okay, once you click on run button, you can see your application is running on this address 192.168.0.103.8080. So that is the 8080. It is coming from here. You can see that is the port address. It is the port address. Once you type that address on the web page, then you will your Raspberry Pi pointer, let's say program pointer, will become inside this login function. So once it comes in login function, it will open the temp.html template. So where is the temp.html template? It will come here in template part. You can see there is a temp.html template. You can open you no need this one, you don't need this. Okay, you can open this template you in text, open with you can use any like text editor. So you can see this is the template here. You can see so this is the template. Here you can see there is the name of that button: forward, left, stop, right, backward. So if you want to change the name of button, you can change from here. If you want to change the color of that button, you can see color also here. For every button, color white, then green, so like red. So this is the template of your web page. It is very simple. It's just HTML page. Then it will call that HTML page. Then your project will be start working on the HTML side. Then once you press the any button, let's say if you press the forward button, then what happen, this first video feed will be start, and whatever the camera capture from that video feed, it will respond on that web page by using this line. Okay, after that, once you press the forward button, then you can see here your motor 1, motor 2, motor 3, motor 4, true false means it will rotate in the forward direction. Then again your web page will be reload. That's why once you press the web page button, like any forward button, you will see some something like blink there on the camera. It again load the camera because your web page is loading at that point. So that's why that blink is happen for the some millisecond time. Okay, once you click on backward button, then again it will come here. It will give the signal on this motor pin, that is for false true. Why this false true? Because it is a motor driver. When you want to move the motor in the forward direction, you have to give IN1 and IN3 to the true value, and other two should be false. Then if you want to move the backward, then IN2 and IN4 should be true, and IN1 and IN3 should be false. So that is the logics I have given here. It is very simple to understand. This is just like when you want to move the motor to left side, so this function will be called, and it will move the motor to the left side by using this line. So for the right side, you can see I have given IN1 to the false, IN2 to the true, IN3 to the true, IN4 to the false, because I have to move right side direction, that's like this. So for this direction, this side of motor should be in the forward direction, and this side of motor should be reverse direction, and that's why your robot should be moved like this. So to rotate that motor for the respective direction, I have given IN1 to the false, IN to the true, IN3 to the true, IN4 to the false. So this is like some combination of your motor pins to move the motor in the left, right, forward, reverse direction. So that's it. Very easy program, very easy to understand program. I hope you understand the program. Now how to run the program? There are various ways to run the program. You can close this. Again I will repeat, you have to load the CV2 library in your Raspberry Pi. So how to install that CV2 library, that I have already explained in my various past video. Please watch that video. Without that one, your project will not work. Okay, now how to run the code? Just go to the plus and then go to this one application, and then double click on this program. Okay, before run the pro, you can stop the project. Before run the project, you should connect your camera to Raspberry Pi, otherwise it will give the error, or it will not show feed on web page. So make sure your camera should be connected to your Raspberry Pi first before run the project. Then now you can run the project again, and once it run, then you can copy the address to your web page, like to your mobile application or laptop, anywhere you can copy this one, just to verify your program is working or not. And just go to the browser, any browser, so and paste that address here and press enter. So once you press enter, you can see the application is working right now, and I can see the live feed also there on that application. You can see live feed also there. Once I press the forward button from here, then on Raspberry Pi Thoni browser, it will show it should show the forward. So once I press forward, and here you can see forward is coming. That means your program is working. Then connect your hardware. I hope you already connected the hardware and run the project, and just plug out your HDMI cable and your project will start working. Okay, now let's see how to run the code on your mobile application. So you can see I open my mobile application. Just go to the Chrome, give the new tab, and the new tab you can type that address 192, whatever the address of your Raspberry Pi. So you can type the same address on your Raspberry Pi like http then 192.168.0.102 and then here port address is 8080 and press enter. So you can see the camera start working and you can see live feed also from the Raspberry Pi on the camera. So in this way you can use the mobile application to run the project. So I hope you understand the complete flow of this project. Now I again repeat the process what you have to do. You have to first connect all the hardware that I explained in hardware connection. Okay, then after that you have to install the flash library, CV2 library in your Raspberry Pi. How to install CV2 library I haven't explained in this video. You have to watch my past video to install CV2 library, or you can use the Google anywhere to install the CV2 library on a Raspberry Pi. Then third, you have to change the IP address of your web page from the that 25 number. In 25 number from the program there is a IP address section. You have to change that IP address at that line. Okay, how to find out IP address I already told you. Then after that you have to just click on run button, copy the HTTP address in your mobile, laptop, anywhere, and you can easily control your Raspberry Pi from the application. So I hope you understand the complete flow, complete project. Please do this project by yourself and please feedback me in the comment. If you have any doubt about this project, then please contact me on my WhatsApp. The WhatsApp number given in the description of this video itself. So please contact me anytime. Thanks for watching this video.